Hello and welcome to this year's Future City Experience. My name is Rebecca White and I'm here on behalf of Engineers Canada and Engineers of Tomorrow, two of three organizations who have come together to make this opportunity available to you today. Engineers Canada works on behalf of the provincial and territorial associations that regulate engineering practice and license the country's 300,000 engineers. We also serve as the national voice of the engineering profession and are very proud of the work that we're doing to engage young people like yourselves, helping you to learn about all the fascinating and rewarding opportunities that you can pursue as an engineer. This is work that wouldn't be possible without the generous support of Natural Sciences and Engineering Research Council of Canada and our fantastic partner, Ontario Tech University, an organization that is helping to train the next generation of engineers. But before we get curious about designing cities of the future, I want to take a minute to acknowledge the lands that we're on today. I would like to begin by acknowledging the Indigenous peoples of all the lands that we're on today. And while we meet on a virtual platform, I would like to take a moment to acknowledge the importance of the lands we all call home. We do this to reaffirm our commitment and responsibility in improving relationships between nations and improving our own understanding of local Indigenous peoples and their cultures. From coast to coast to coast, we acknowledge the ancestral and unceded territory of all the Inuit, Métis, and First Nation peoples that call this land home. Please join me in a moment of reflection to acknowledge the effects of residential schools and colonialism on Indigenous families and communities, and to consider how we can, each in our own way, try to move forward in a spirit of reconciliation and collaboration. All right. You are all here today because you have accepted our challenge to try and design a waste-free city. This is no easy task. So to help you get started, we have sought out experts that are doing this work in real life, researching, testing, and designing ways to help us live more sustainably. To get you started thinking about this project, I'm going to pass you over to our moderator for today's event. Dr. Daniel Hornweg is an associate professor at Ontario Tech University. For almost 20 years, he worked with the World Bank, including as lead advisor, overseeing sustainable cities and climate change programs. He was the Chief Safety and Risk Officer for the province of Ontario from 2012 to 2020. Dan began his career in waste management, working with the City of Guelph and Region of Peel in Ontario and the government of Bermuda. He has worked with more than 400 governments on waste management and resource issues and published extensively in the sector. Dan is a fellow with Canada's Transition Accelerator and the Global Cities Institute at the University of Toronto, and he chairs the Region of Durham's Roundtable on Climate Change. Dan researches energy and material flows of cities and urban systems. Very busy guy, so please join me in welcoming Dr. Dan Hornweg with us today.
Thanks, Rebecca. Greetings, everyone, and welcome. I guess today we're going to talk trash and see if we can build some sustainable cities. And to start us off, we have, I think, a few questions. And I think the first one is if any of you have actually met one of those 300,000 engineers that Rebecca mentioned in Canada.
And maybe I'll just jump in to bring to everyone's attention to participate in the poll that Dan is sharing with you right now. You can go to slido.com and use the code you see. I see some answers coming in. And that is also where you can submit the questions for the live Q&A portion of today's event.
Wow, we engineers need to get out there more, I guess. Ha, 50-50. Uh-oh. Okay, well, we're almost at 50-50. Maybe after today, you get to vote again and it'll be, oh, see, 50-50. Well, engineers disguise themselves quite well, but hopefully after today, some of you will want to become engineers and maybe build a few sustainable cities or work on the ones you're in. For our second question, I think, are we on our first question? Yes, now this is a tough question. Do you think that we'll live waste-free someday? Yes or no? Seems 50-50 is a good bet all around today. So, oh, okay. So, we keep losing our 50-50 has gone to 90-10. Well, for sure, it won't be easy. I think that's 100% certainty. Okay, so it looks like we have our work cut out for us today, which brings us to our third question. I'm nervous this will be a hard project. Well, based on question number 2, maybe. Okay, so it looks like 2/3 of you this time. Oh, we might hit 50-50 this time again. Hard and you've got this. Okay, well, we'll help. We can't promise that it'll be easy, but hopefully we can promise that it'll be informative and fun. And with that, our 4 people of fun and information. I'll introduce our panelists quickly, just by name, and then they can introduce themselves a bit more. But we have a great group of panelists from across the country. We have Monica McKell, who's joining us in BC. We have Vanessa Raponi, who I think is in Hamilton, Toronto. Steve Rakoczewski, who I think is also in Toronto-ish area. And Karen Story, who's in British Columbia as well. So that's our panel, and we are ready to see if we can get waste-free. And thanks again for joining us.
Hi, everyone. Thanks, Dan. Did you want us to go around and introduce ourselves now?
Sure, that probably is the easiest.
Okay, great. Hi, everyone. My name is Vanessa Raquel Raponi. My pronouns are she, her, and yes, I'm joining from Toronto and went to university in Hamilton, Ontario at McMaster. I have a pretty cool job. I'm actually a toy engineer. So you may not know that there are engineers behind all the toys that you play with every single day. And there's different types of engineers involved. There's product development engineers like me who help the designers who create the concept get that idea all the way to the store where you're buying the product off the shelf. You have manufacturing engineers who work in the manufacturing plant and make sure that everything happens in the plant to actually manufacture the individual toy. You have electrical and mechanical engineers who will work on a part of the toy and make sure that part of the system is all set. And the reason I'm here is that I actually have a couple examples with me right now, like our Rubik's Cube or our gun teddy bears. I've run our sustainable materials committee at Spin Master for 3.5 years now, where we're basically trying to figure out ways to take these plastic products or fabric products and find sustainable alternatives. So we did many years of investigating, and we found out that recycled resin or recycled fabric, which means that the input of the plastic, instead of coming from the ground or oil, instead of that, it's just a recycling process of already existing plastic. That is now the inputs for this. So this is a 100% recycled teddy bear. All of the fabric, all the thread, all the paper, the label, the stuffing on the inside, it's all 100% recycled. And this is a 100% recycled Rubik's Cube as well, which is coming on to market. I think it's already on market and it's called the Rubik's Recube. So I'm really excited to share those stories with you on behalf of toys, on behalf of plastic, and really excited for this project you're working on. Thanks, everyone.
Thanks, Vanessa. Who wants to go next? Maybe Karen?
Oh, there I am. Hi, everyone. I'm Karen Story. I work for Metro Vancouver. And Metro Vancouver is a local government. So unfortunately, we don't get to play around with toys, but we do serve over 3 million Canadians, about 10% of the population. And my department's job is to oversee the management of our regional facilities, which include a waste to energy facility, a landfill, and several waste and recycling centers where residents can drop off their recycling and their garbage. And this year, we're also focusing on making more opportunities for our residents to go to places where they can drop off their items for reuse, also where they can learn how to repair items that have broken, but they still love. Other things that we're targeting for this year are ways to reduce the amount of food and yard waste in the garbage. There's a lot of apartments that still dispose of their food scraps in the garbage, along with some food businesses that haven't diverted their organics yet. And we know that when these items go into the landfill, they make methane, which is a powerful greenhouse gas. So we're working hard to improve that. And we've already done a lot since we banned organics from disposal in 2015. We've removed the equivalent of 250,000 cars off of the road with our green bin program, but there's still more work to do. And we are leaders in North America. We divert about 65% of the waste, double the national average. So you can say that my job is to make our region waste free. And we need more ideas. So I'm looking forward to sharing what I have learned and also hearing from you about your ideas on how we can build a waste-free city together.
Cool. Thanks, Karen. Rebecca? Oh, sorry. Steve, I jumped the gun there.
Hey, good afternoon, everybody. Welcome to the kickoff today. Really excited for all of the projects that you guys are about to start up with. My background is I started out actually as an engineering technologist, and over the years I transitioned into business development here at Enbridge Gas, which is a gas utility in Ontario. The first number of years that I worked at this company, I worked in energy efficiency and energy conservation, working with our customers manage their energy resource that they needed to run their businesses and operate their buildings. In the last couple of years, I've worked in the renewable natural gas area of industry, and that's really working with organic waste streams and trying to figure out how we can work with producers of renewable energy, take those organic waste streams and convert them, clean them, and deploy them and use them across the energy system so that they can take the place of greenhouse gas emitting fuels out there in the energy system. And so I'm really thrilled to be part of the conversation today to really challenge our thinking and come up with some good creative takeaways that you guys can all apply to your projects this year and the next couple of months.
Okay.
So thanks so much.
Thanks, Steve. And last but not least, Monica.
Thanks, Dan. Hi, everyone. I'm really excited to be here. So my name is Monica McHale. I'm actually a graduate student from the University of Waterloo, and I'll be heading over to the University of Victoria. I think my job is the coolest because I just get to learn a bunch all day. So I'm just like you, still putting on my student hat. In the past, I finished my undergrad degree in chemical engineering, and I have a vitamin box near me. That's the closest example I could think of. So to make any vitamins that we might take all day, there's a series of steps that we go through, and that's kind of what chemical engineering is. It's like process design. So thinking about how do we go from raw materials to vitamin, or how do we make the packaging for the vitamin, how to make sure everything is quality controlled and nice and clean. In my master's work, I took an interest in energy, and I actually looked at a case study building, like an office building, and saw how it was using energy, and it was trying to generate its own power using solar panels. So that was a really exciting opportunity. And as I move to PhD studies, I'm really excited to look at mass renewable energy generation. So looking at how we can make solar farms, wind farms, and really produce a bunch of more renewable energy. So I'm really excited to learn about your ideas for a circular economy type of waste-free city. And I'm really grateful to be here.
Great. Well, thanks, everyone. Rebecca and Sydney, correct me if I'm wrong, but send in your questions as much as you like about circular waste, cities, sustainable cities, and maybe we at the in the panel will kick things off with just a small question. What are some of our key challenges that cities face in terms of sustainability, and how might they be addressed? Wow, that's like one of those final exam questions that is one question on the whole exam. But maybe does somebody want to start with that? Why don't
I can go ahead, Steve, or I can take a stab at it. So for me, being an engineer, my first approach to a lot of these challenges about zero waste cities is first getting into infrastructure. So that's kind of what Steve and I were talking about with respect to having the facilities that can create a sustainable fuel out of the organics that people are putting in their green bins. But then beyond that, there's so many other challenges where you have to change the culture of the city and convince people that recycling and reuse and repair is the right thing to do, even if it's a little less convenient than throwing things out. And then the other big challenge, which I think is where engineers can also really thrive, is redesigning things, because there's certain things that are going to disposal in our region right now that we have no options for diversion or making into something new. So we either need to find new solutions to process them into valuable materials, or we need to redesign them in the first place.
Great, thanks, Karen. And Steve, did you have?
Yeah, I dug up some stats earlier today, and I think the way I'd start out is by saying, you almost have to think about what's happening today and then what's happening in the future, as I think this initiative is really challenging all the classes to do. And Statistics Canada states that Canada's population is expected to increase from 38 million as of last year up to almost 57 million in 2068. And this means that our country will have almost 50% more people in the next 35 years. And so we know people demand resources to live, and accessing these resources require effective strategic planning, and it costs money and effort. And so I think this increase in resource demand means that we have to be creative, open-minded, and collaborative to make sure that the best ideas are used in these plans so that all of our basic needs are met, and done so in a way that you can deliver benefits to more than just one area. So I think that's kind of my contribution to that question.
Okay, thanks. Monica or Vanessa, did you have anything, or do you want to move to the next? Just jump in, all four of you, if you like. I can see if your mics are off.
I'm all good, thanks though.
Okie doke.
I guess
One
I can
thing-
add, oh, sorry.
No, go ahead.
I was going to add, like, with any of these initiatives, something that I'm looking at is also how the local community can get involved. So when we start thinking of solutions, I think it's also important to think of who can help us with these solutions, and how can we meet the community's needs rather than just coming up with technological solutions that the community might not accept.
Great point. And as most of us are Canadians on this call today, I should probably add that, that I think Canada has a bigger role to play than almost any other country. Canadians per person use more energy and generate more waste than anyone else in the world. And there's a lot of people in the world that have, maybe 1/100th in terms of how much energy they use compared to Canadians. So we have a big job ahead of us as the rest of the world is trying to catch up to us. But as Steve says, we need to really focus on conservation and reducing what we end up using. So it's better not to produce it in the first place than to try and get rid of it after we've used it. So what is the best way to recycle? The answer might be not to produce it in the first place if we can get away with that. Okay, so maybe on to question number 2. How can urban design and planning promote sustainable transportation options such as walking, biking, taking your scooter, public transit? Anyone want to tackle that one?
Hey, Dan, I just wanted to hop on for a sec too, just to make sure, bring your attention to the participants are upvoting on some of the questions on the screen there. So if you want to make sure you get your questions answered, you can click on the questions that you like that you're seeing, and then we can make sure we get to those questions too. Sorry to interrupt.
No, that's great.
Yeah, I don't know if you can see them there.
The one, what made you want to do this? What inspired you? That's a great question.
Isn't that a good question?
Oh,
Yeah.
yeah. Well, who
Yeah.
wouldn't want to work in a toy factory?
Yeah.
Yeah, what made me want to do this? I would say that for me personally, as a materials engineer was my background, and I'm also from Toronto. So it was exciting for me to move back to the city. And then with my experience in materials engineering, I actually did a lot of manufacturing engineering. So with that and trying to move to Toronto, I found this role that was actually kind of the step before manufacturing and product development. And the toy part honestly was fully by accident. Like, I had worked in plane manufacturing, I'd worked in food and beverage manufacturing. So never really toy, but it was similarly like consumer packaged goods or mass manufacturing of something. So that's sort of how I got here. But then once I was at the job, I was just so passionate about, the sustainability side. Like, anyone in manufacturing, you're producing like a human being's lifetime worth of plastic, like per product per day. So it's just, we're talking about scales. Like, basically the way I think about it is, if I've ever personally tried to recycle something or make a conscious sustainable decision, if I take that spirit and apply it to one of my products, like, we make 5 million Rubik's Cubes every single year. So being able to impact this is just such a larger scale and volume of plastic than I could ever reasonably impact in my own life. So that's why I'm so passionate about doing it on the toy scale.
Cool, great point. And if any of you visit a landfill or an incinerator, you will be amazed at how many toys are in the garbage, sadly. Okay, what else? Oh, that's a great question about renewable farming and agriculture, and another important task in becoming zero waste. Well, okay, I've jumped in with my opinion. I would say yes, but does anyone want to comment on that from our panel?
I think what people don't always realize is there's a lot of waste that happens, as Vanessa was talking about, in advance of the food actually getting to people's houses and getting to the grocery stores. And so I think looking at that system holistically is definitely the way that engineers need to look at things moving forward, instead of just focusing on reducing waste that's happening at people's homes. We need to think about the whole system, including the farming. So I'm really impressed by that question. It's very insightful, and it's definitely the direction that we're moving as engineers, is systems thinking.
Exactly. That's the cool engineering now, systems engineering. Okay. Anyone else?
I can jump in on the, oops. Can you guys hear me?
Yep.
Okay, yeah, I see the one poster saying, do you have any ideas for ways to use a circular waste economy in our cities? So I guess I almost think of waste as like that game, the floor is lava. You don't want it to touch, you don't want to touch the ground or else it's going to burn up. You don't want waste to kind of sit in a pile and just be nothing and not utilized or recovered and transformed. And so I think what cities have an opportunity to do, and it's already started in different parts of the world, but in particular with City of Toronto, I think they've looked at their waste resources at green bin processing sites, landfills, so on. And what their intent is to transform that organic waste, make a biogas, get it into the utility grid, send it into a fuel dispenser to fill up their garbage trucks, which then go and pick up the green bin waste, and then the cycle repeats itself. So that would be one pretty elegant sort of circular economy solution that cities can certainly consider, have done, and you know, we as a utility are helping to be a partner in solutions like that.
Cool. Okay. Any other thoughts?
I have some ideas also about some cool examples of how circular economy is being implemented in our city. So there's one company locally called Chop Value, and they take chopsticks and make it into high value furniture material. He's a PhD in engineering in how to make wood products, and he's taken the chopsticks and figured out how to make them into beautiful pieces of furniture. I think that's one really cool idea. Another thing that we're seeing a lot more is kind of going back to how things were. So there's a bunch of zero waste grocery stores and zero waste dispensaries, they're called, where you can go and bring your own containers and fill them up instead of getting a bunch of containers when you go out to buy your groceries. You can simply fill up your soap container, and then there's no waste in the first place. So there's lots of ideas out there that people are finding to implement a circular economy in cities. And I do have one that's up there that I think Vanessa would be great to answer. Where do you get your recycled material from for your toys?
Yeah, that's a great question. So what's really interesting about our process and products is we're talking about products like the Rubik's Cube, which have millions and millions of pieces and are distributed all over the world. So some of these awesome examples, like, you know, you hear of some bio-based options where it's like seaweed or, you know, turning into a plastic. Sometimes they're kind of on a much smaller scale, so we don't have as easy access to them for this mass global production that my business is talking about. So for us, for these two things, fabric is, especially these types of fabrics, are something made of a material called polyester. And when you look at what your water bottles are made of, which is called PET, you can actually kind of translate the PET into the polyester fiber into the fabric. So this teddy bear is made from water bottles, and water bottles and PET recycling is one of the most globally available recycling systems that exist in that circular economy, because it's a much more sophisticated and easy process to recycle. So that's very readily available. However, this Rubik's Cube is made of a different plastic material because there's a lot of mechanical tension requirements on the cube. So there's more that this plastic needs to be able to do from an engineering standpoint. So this is made of a material called ABS, and that plastic is way less readily available in bulk. So what we have done is we've worked with another vendor, another business, and they work with multiple companies like TV manufacturers, refrigerator manufacturers. There's these things called pallets, which is they're these big plastic pieces that you store other things on in a warehouse when you're shipping goods. So basically, that recycler takes all of these excess scrap parts of these giant parts of TVs, refrigerators, pallets, things like that. And then they know that those products that are incoming are 100% this type of ABS plastic. So they do the whole grinding, processing, purifying. And in a product like this, you have black plastic, but you also have these highly vibrant colored plastics as well, which means that you have to add color additives. So they do all of that for us, and then they ship that plastic to our factory. And we use what's called plastic injection molding machines, and we just put that recycled ABS right in there. So it comes through a chain of what we call supply chain, but it does successfully get into your Rubik's Cube, and then you can play with it when you get home and see how quickly you can do it.
Wow, these questions are great. I would love to just copy them all down, and this would be a perfect first year exam on sustainability. I love it. I'm not sure if anybody wants to jump in and try and answer some of these. Like, which type of sustainable energy do you see being used in the future? Well, that's a great question. One thing, there probably is there is not anything that is really a sustainable energy. Everything we do with regards to energy, resources, has an impact on the planet. And the goal is just to make that impact as little as possible. So we're getting there. But wind and solar and hydro are better, but dams cause problems. So it all helps, but we need a lot more of it. I don't know, maybe Monica, did you have any thoughts from energy and materials?
Yeah, I think I can add to that. Like you said, there are trade-offs, and it really depends on which phase you're kind of looking at. Because when we look at solar panels, they're great for reducing emissions, while in the operations phase, but we have to also remember that we needed to mine all the metals that they needed to make. So there's that extra phase. And then at the end of life, we'll end up with a bunch of waste that we need to kind of recycle and recover all those rare earth metals. So it's really important to consider which area is the problem that we're trying to tackle, right? So if I was really trying to tackle, I don't want to have any emissions during operations, then yeah, that's a great solution. But then I might be shifting some of those emissions to the start of life or end of life. So we just need to have other processes in mind to kind of transform that waste, so we don't end up with a pile of battery waste or solar panel waste at the end of the day, right?
Yeah, great point. There's no free lunch, I guess, when it comes to the environment or the economy. The trick is just to find out how to reduce the cost as much as possible, I suppose. So, and And is there plastic that can decompose? Yes, it's biodegradable plastic. And that sort of leads to this question, if we were to make everything biodegradable, would this help or hurt the environment? Again, it would help a little bit, but it probably wouldn't help as much as we hope. Sometimes we end up doing a lot of these things that companies want us to do because it seems like we're helping sometimes more than we really are. But I think someone mentioned earlier, the biggest help we can provide is this challenge of changing our lifestyles, the size of our houses, the size of our cars, the energy we use, how much material we use, and really what defines us as being happy. It doesn't need to be the more stuff, the more happy.
Yeah, Dan, I actually have a lot of thoughts about biodegradability.
Perfect.
So for my company, when we first started the sustainability journey, as I said, we have lots of different plastic types that we use in mass manufacture. So our assumption when we first started the journey was that biodegradable plastics was going to be the obvious answer. And we spent a whole year investigating biodegradable plastics. And it was sort of that perception of like, you know, the turtle that eats the plastic in the ocean, and that's what we're trying to avoid. So that's why we were focused on the end of life of our products. But actually, what was interesting was the more that we explored biodegradability, because something like a Rubik's Cube is going to be in your family and in your home for many, many years, it's not something like a straw or a reusable or a disposable fork where you're just going to use it once and throw it away. Because of the longevity, we had to use a type of biodegradable plastic called anaerobic biodegradation, which means that it'll degrade in an environment that has no oxygen, no air at all. So this is sort of a scenario where in the landfill, it's buried under the ground, and that's what will help it degrade. So we sent these samples to a lab in India that had this biodegradable additive, and we watched our plastic products degrade at a very rapid pace. However, when there's some principles of, you know, physics that energy is neither created nor destroyed. So as the plastic physically was degrading, it was just being converted into gas. And we call this equivalent kilograms of carbon dioxide, or EQCO2. And we were seeing that methane, or CH4, was actually 4 times more impactful than the CO2. And the amount of off gases from this rapid biodegradation was so much, it was the same overall quantity of gas if we were to let it degrade over a 20-year cycle, but we were just speeding it up to a 1-year cycle. So we weren't reducing that amount of carbon emission offset. We were just making it happen way faster. So this is why if we were to do that as a mass manufacturer and every single product of ours had biodegradable plastics, the amount of equivalent kilograms of carbon emissions we would be giving off would have a dramatic impact to the environment that would be really, really negative and impact the ozone layer. So for this reason, we started to explore what we call a life cycle analysis, which is where you take the language is called cradle to grave. So cradle is all of the raw material inputs all the way to grave, which is all of the way that the product degrades. And we assess the carbon emissions during every stage of that. And what we learned was that for our products, over 80% of our carbon emissions come actually from the beginning of life, or that cradle phase. And it's all from that moment where we extract the oil from the ground to create the plastic pellets for our plastic products. So this is why we decided, instead of leveraging biodegradable plastics at the end of life, it's better for our product and the use that it requires to focus on the beginning of life, which is why we changed to recycled resin inputs, and that impacts over 80% of our emissions per product. So when you're considering your zero waste future cities, you should think about that kind of cradle to grave. So maybe at first it was easy for us to just think, oh, the input of my toy is plastic pellets, but we had to go a few steps earlier than that. And what creates the plastic pellets? Well, that's the oil extraction from the ground. So kind of really thinking very, very holistically of from all the way from the beginning to all the way to the end. And maybe you'll come up with some really cool ideas.
Cool. Thanks.
I know that was a very extensive answer on biodegradable and compostable plastics, but I just want to mention that we find the same challenges with short-lived plastics, so straws and cups and containers made out of compostable plastics cause a lot of challenges in the system. They don't typically degrade as fast as the carrot peels in the systems. And so what we're hearing from the composting facilities and the anaerobic digestion facilities where the food scraps go and get processed is they just screen them out and send them to garbage. So our message is no plastics, not even ones labeled biodegradable or compostable, go in the garbage. And what we're trying to encourage people to do to make the world a cleaner place is to really think about how we can move towards reuse. So I'm not saying go out and buy another reusable bag or go out and buy another reusable cup. I'm saying go and take the one that you already own and make a habit of bringing it every time you go get a drink. Make sure you tell your parents to bring your reusable bags every time they go grocery shopping. And these kind of efforts multiplied by all Canadians across Canada are what's really going to make a huge difference. And the last area that I think we can all make a big difference is in clothing. So a lot of us donate our clothes, which is great, but very few of us go to the thrift store and buy used clothing or repair them. And so these are some simple things that everyone can participate in order to really reduce our waste and have zero waste cities. And I see Steve is burning to say something, so I'm curious what that is.
For all the kids out there that don't know who she is, look up Punky Brewster. She had patches galore on her clothes. It's an old TV show, and it was super cool looking. And I've got my kids wearing clothes with patches, and it's great because we extend the life of all the clothes that they're wearing, which mostly are hand-me-downs from friends. We have a network of families that have kids of different ages, and we just share clothes as kids get older and out of them. And certainly it's a little different than my experiences growing up. And I think it's one of the simple ways that we all can contribute today, towards mitigating, I guess, that type of waste. So Punky Brewster, that was my offering there.
Wow, what advice you're getting today. This is great. So, well, here's a tough question. How can teens help make the world a cleaner place? Yeah, great question. Because it's never fun initially, I suppose, to be the person to say, just be happy with less stuff. But at the end of the day, that's kind of where we need to move to, is an economy that just uses less stuff, less energy, less material. The things that we buy are far more durable. They may be more expensive, but they last us longer. A lot of times we get people will ask us, is an electric vehicle better than an internal combustion engine? And yes, but obviously the better alternative is to take your bike or to walk or to take transit than an electric vehicle. So we're getting there. And the question about teens, one of the things that I find most interesting talking to people in school at the moment is that you're really going to be the age group, the group of people who basically have to fix the planet. And that means fixing the economy and the way we use energy and material. There's lots of adults that want to help you, obviously, but it's going to be an enormous job, especially for Canadians, because we've got more to do than most countries. So I don't know what other questions we have here. Does pricing of, oh, that was a good one. Pricing affect, oh, I've lost the question now. Does pricing affect how we make eco-friendly choices? In a word, yes, but I don't know if anybody wants to talk about that. Maybe Vanessa, if you could make a toy that would last for 100 years and everybody could hand it down to their kids, but it would cost $1,000, would it work?
Yeah, that's a great question. I love all these questions and love the passion in the room. Yeah, so pricing has a really interesting impact in this conversation because firstly, you sometimes have to pay a little bit more money to put these different sustainable materials into the product, which means that I, as a manufacturer, have to spend more money to make one Rubik's Cube, which means that when I sell this Rubik's Cube to Walmart, who will then sell it to you, we are now all making less profit because we've spent more money per product. Now, unfortunately, the way the world goes around, people don't like to make less profit. They want to make more profit. And there's lots of reasons for that. You know, we all need to feed our families and be able to, you know, live in this world. But sometimes the amount of profit is able to be adjusted ever so slightly if it's not going to be that big of an impact. So that's on the element of us just paying for it. But then when it gets to the consumer, so say we had to spend a lot more money, and say we currently sell a Rubik's Cube for $10, but maybe we have to spend so much money that we have to actually sell the Rubik's Cube for $15. But if for all time ever, consumers have been used to buying a Rubik's Cube for $10, that $5 to pay for it, even if it has a sustainable element to it. So a lot of the challenges I face is trying to keep it the same, which is really tricky. And I would say that sometimes there exist consumers who are willing to pay more, but it's sort of unreasonable. You know, if you're working really hard 40 hours a week as, you know, a McDonald's front of house staff, and you know, like, are you really going to be the person who is going to be able to spend extra money on all your consumer goods? Like, it's not really reasonable to expect every single person to be able to spend more money for the sake of sustainability, which is why it's on me as the manufacturer to come up with solutions that don't impact the customer.
Cool, great, thanks. Monica, do you have any thoughts about all that stuff heading out to Victoria? I'm envious, by the way.
I guess I can take a stab at the question about the pollution being used to make energy. And I think something that comes to my mind is carbon sequestration. So that's when we capture carbon from the air and we bury it deep underground into rocks. And I guess eventually it will make more oil, but it's a really interesting process to kind of start a bit of a cleanup procedure where we capture a bunch of our emissions and bury them deep underground.
Cool. Okay.
Hey there, I just had one topic to piggyback off of that topic, or off of that question. There's a facility here in Southern Ontario, St. Mary's Cement. It's a big cement manufacturer, and they have large stacks of exhaust that have carbon dioxide that are getting exhausted from the facility. And they have and I don't know what's happened in the last couple of years, but I visited there a couple of years ago where they have a little pilot facility, a little pilot plant where they've taken some of that waste exhaust and they've injected it into a facility that is basically growing algae and different products, green products, nutritional products that can then be repackaged and sold on the marketplace across a wide variety of different types of end uses. So that's one example where it can actually be converted and made useful and perhaps drive some profits in a new line of business that you know, people like you and I can decide to buy. So that's just another add-on there.
Good point. Okay. Anyone else? Why is recycling so important today? That's a great question. So there's a new metric. You're going to hear a lot about this as you move into college, university, getting jobs, but the circularity of the world's economy is now being measured, and we're actually going in the wrong direction. This year they estimated it's about 7%, it's about 5% only in Canada. which means that all the materials that go into our economy, 95% of our material is just there for one-way trip, headed to the landfill or the incinerator or wherever. And the goal is to be 100% circular by, well, the goal is 2050, but you're going to have to work really hard to get that. But it would be a good goal. It'll be interesting to see every year. You'll be able to see how much we've improved or not on our amount of circularity. Okay, does anyone, I think we're supposed to wrap up in about 5 minutes. I don't know if our 4 esteemed panelists want to give a crack at summarizing some of these questions. Maybe if we started, Monica, do you want to give it a try? And then why don't we go from, well, you're in Waterloo at the moment, but we'll start in Waterloo and then go to Vancouver.
Yeah, for sure. So I think a lot of really great questions today touched on how we can transform the different waste streams in a city into usable products, or even how can we reduce them. I was really impressed with all of the students' questions and how enthusiastic they are about the Future Cities Challenge, and I'm really looking forward to seeing their projects.
Great. Okay. Karen, did you want to go next?
I think I heard Karen. So we're in Vancouver already.
Oh yeah, we go quickly in this fast-paced world.
Great. Yeah, I mean, there's so many things going to garbage right now and so much opportunity to turn them into value. And I really want to stress something that Monica said, which we really find important, which is you have to find solutions that work for the community, in addition to working technically. So that's the Engineers of the Future's challenge, is how can you make it work for people? And there's a lot out there. We'll send out some resources to answer some of the questions that we didn't get to. Over to Steve.
Yeah, I totally agree. Just because there is a challenge perhaps that's non-technical and it has to do with community concerns and so on, it's really an opportunity to apply pressure and try to figure out and work together to overcome those challenges and get to a better place with how things are done. I know that's certainly been the case with various renewable energy facilities and working with those communities that they reside in. I guess one takeaway that I would offer before we break off here is any of these solutions that you guys are trying to come up with, because you guys have lots of different diverse thoughts and questions here. I would just ask you to think about how many benefits can be generated out of the effort that you're seeking to undertake. So in the case of recovering organic wastes and converting it into a usable energy, you're basically ending up you're taking a waste stream, turning it into that usable energy, but you're also recovering some leftover organic material, which is called digestate. And then that digestate can be reapplied oftentimes to land that is used in farmers' fields and so on. And so that's an elegant solution in that you're taking a waste problem, you're contributing to the energy problem with the solution there, and then you're also adding a bit of circularity and restoring some of the nutrients back to the land. And so I guess that would be my ask of you, is to think about how many benefits can be derived from your solution. But pleasure to be here, guys, today, and great of luck. Best of luck with you guys moving forward.
Thanks, Steve. Vanessa?
Yeah, I think I had a wonderful time in this panel discussing what it takes to make these cool, sustainable products. I hope you've all learned something really interesting, and the next time you play with your toys or develop your future cities, you can think about these lessons. I encourage you all to just consider leveraging what is possible within your world to help make the planet a bit more green, and really excited that you all are participating in this project, and we can't wait to see the end results. Thanks.
Well, I would first like to thank all of you for joining. Thanks. I mean, yeah, I mean, a journey of 1,000 miles begins with a single step, and it really is just joining some webinars like this and working with your teachers on where do we go from here, what needs to be done. I want to thank the 4 panelists, and Rebecca and Sydney, and yeah, and just sum up and say thanks. And maybe the one comment I would leave is it does look like an enormous, daunting challenge sometimes, but the good thing is we actually know how to do this. It's not a technical issue. It's more of rolling up our sleeves and getting down to work. And that's something that everybody can help with. So thanks for taking the time, and thanks for caring. And we'll see you out there.